Well, here we go. The limiting and excess reactants movie that you've been waiting for. So this is going to clear up all your questions, I hope. So we're going to start this video with a little joke. What do you call a joke that's based on the elements cobalt, radon, and yttrium? Well, it's kind of like me, a little corny. All right, so where are we? Let's start with another real life example. Real life. Well, hot dogs are real life. So if you have a package of hot dogs that only has 4 hot dogs in it, and you have a package of buns that has 8 buns, okay, you already know where this is going. You get 4 hot dogs in a bun. Well, that's kind of a bummer because you're left with 4 buns left over. In this case, the hot dogs are getting out first, so they're the limiting reactant, and the buns are in excess. So unless you like peanut butter and jelly sandwiches on buns, you have extra buns lying around. Now, we've done lots of these analogies, and I think you're pretty comfortable with this idea that the limiting reactant runs out first, the excess reactant you have left over. Now we're going to relate that to what we've learned about stoichiometry. And here's where we use everything we've learned this term. Okay, so back to stoichiometry. We're going to start with an example from a lab that we did in between Thanksgiving and Christmas. This is one of the reactions we did in our 6 solutions lab. So if we have zinc and we react it with hydrochloric acid, we get zinc chloride and hydrogen gas. So we're going to start this problem, and I want you to work this problem along with me so that you have it in your notes. Okay, so you can use this document, download it from Sundial, and go work with me. All right, so the question says, if you start with 18 moles of zinc and 30 moles of HCl, how many moles of zinc chloride are produced? Well, in order to answer this question, we have to determine which is the limiting reactant, and we have to determine which is the excess reactant. Now, just like in the POGIL examples, there are 2 ways to do this problem. So I'm going to show you both. The first one, we're going to use the strategy of figuring out how much zinc chloride would be produced starting with either of those reactants. So we're going to set up a simple mole ratio problem. All right, so as with every mole ratio problem, you start with what's given in the question. So we know we have 18 moles of zinc, so I'm just going to put 18 moles of Zn. And we also know that we have 30 moles of HCl. All right, so let's start with the zinc first. We're going to use the mole ratio from the balanced equation to convert from moles of zinc to moles of zinc chloride. Okay, so I'm going to put a parentheses, control question mark. In the parentheses, I'm going to use the coefficients from the balanced equation like we would with any mole ratio. What we're looking for is ZnCl2, so I'm going to put that on top. I have a 1 because there's no coefficient in front of it. And if you notice, there's no coefficient in front of the Zn either, so it's a 1-to-1 mole ratio. And you guys already know what's going to happen. 1-to-1 means it doesn't change. So we get 18 moles of zinc chloride. Now let's do the same thing if we start with 30 moles of HCl. Now many of you are already figuring this out in your head, okay? And I know you can do this in your head, some of you. But for those of you, to be consistent, I want to give you a strategy. Okay, you're probably wondering, well, why do we have to go through all this? We already know the answer. All right, so we're going to do another mole ratio. We're going to still calculate zinc chloride. So 1 mole of zinc chloride goes on the top. And this time we're starting with the 30 moles of HCl. Well, we have a 2 coefficient. So we're going to put 2 moles of HCl on the bottom. Shift return. And look what we get. Now we can actually get an answer. If we react completely 18 moles of zinc, we get 18 moles of zinc chloride. If we completely react 30 moles of HCl, we only get 15 moles of zinc chloride. So there's your answer. We have answered 2 questions at once. We know that the maximum of zinc chloride we can get from this reaction is 15 because it's the least of the 2 results. We also know that since the starting with 30 moles of HCl produces the lower number of product, then that has to be the limiting reactant because that's the one that's running out first and stopping the reaction when only 15 moles of ZnCl2 are produced. Okay, so we've answered two questions at once, and I'm going to write them in here. Here's our answer. Well, we know that HCl is the limiting reactant. I'm just going to abbreviate it LR. And therefore, if HCl is limiting, the other one is the excess. Zn is the excess reactant. And we also know that we got 15 moles of ZnCl2 produced. All right, so that's the first method. Now I'm going to show you how to do it with the second method. Now, just so we know what we're starting with, I'm going to copy the reaction and put it down here. Okay, so method number 2, we're going to use one reactant and we're going to calculate how much of the other reactant is needed. Okay, so in our original problem, we're starting with 18 moles of zinc and we are starting with 30 moles of HCl. Now, either way will work. We'll get the same answer, but it's a different technique. Okay, so what I'm going to do is I'm going to start with the 18 moles of zinc, and I'm going to use that to figure out how many moles of HCl are actually needed to react completely with that amount of zinc. So instead of doing the mole ratio to the product, I'm going to do the mole ratio from one reactant to another. So I'm going to do a control question mark. I'm going to put 2 moles of HCl on the top and 1 mole of Zn on the bottom. So you notice what I get for my answer. What I've found out is that it requires 36 moles of HCl to react completely with 18 moles of zinc. Well, that's a little bit of a problem because if you notice, we only have 30 moles of HCl available in the reaction because we're starting with 18 of zinc and 30 of HCl. We need 36, so we don't have enough of the HCl. So therefore, what that means is, again, it's another way of answering the same question. HCl is our limiting reactant. Now, let's try it the other way so you can see it would work whichever reactant we started with. So now, what if we said, how much zinc do we need to react completely with 30 moles of HCl? Well, I'm going to put 1 mole of Zn on the top, and I'm going to put 2 moles of HCl on the bottom. And, okay, we need 15 moles of zinc to completely react with 30 moles of HCl. Well, if you look at the original problem, we start with 18 moles of zinc. And you're probably thinking, aha, we have more zinc than we need to react with that HCl. So yet again, this proves to us that HCl is the limiting reactant because we only need 15 moles of zinc and we have 18 moles available. Okay, either way, you find out that HCl is the limiting reactant. Now, to figure out the amount of product formed, you have to base it on the limiting reactant. So once you have determined the limiting reactant, then you're going to use that to figure out the amount of ZnCl produced. So we know we have 1 mole of ZnCl2 for every 2 moles of HCl. So if we do this right, we should come up with the same answer. Both methods give you the same answer. 15 moles of zinc chloride is produced. Yep, same as the last time. Okay, so method number 2, you're figuring out how much of the other reactant you need and comparing the amounts. Method number 1, you're going straight to the chase and figuring out how much product is produced and then choosing the limiting reactant based on the lower of the amount that's produced. Now what I want you to do is I want you to pause the video and I want you to try the second example on your own. Use the first one as a model and see if you can set it up. Then I'm want you to start the video again, and I'll walk you through the problems and show you the answers. Okay, here we go. Here's another reaction everybody loves. It's the combustion reaction of ethanol. We also did this one in the lab. Okay, so method number 1. We want to know how much water is produced. So in method number 1, we're going to use both starting the reactants, and we're going to figure out the water. We've got 1.75 moles of the ethanol, C2H6O, and control question mark. We're going to figure out how much water. It's a 3-to-1 mole ratio, so 3 moles of H2O. Again, these mole ratios come from the balanced equation. 1 mole of C2H6O. You're probably wondering, why did that go in the denominator? Well, remember, whatever you're starting with in the given problem has to go in the denominator, so it cancels out. Okay. Oh no! Units didn't match. There we go. So the first thing we found out is that if we react all of the ethanol, 1.75 moles, we're going to get 5.25 moles of water. Well, let's see what happens with the oxygen. We have 4.32 moles of O2. And let's do our mole ratio, control question mark. 3 moles of H2O. And, ooh, it's a 3-to-3. O2. Okay. 4.32 moles of H2O. All right, so which one's the limiting reactant? I can tell. Can you? Is this what you got? Well, from this calculation, it looks like oxygen's the limiting reactant because it will produce the least amount of water. And we've answered 2 questions at once. We also know that we're going to get 4.32 moles of water. Okay. So I'm going to go ahead and write that in there. My answer is 4.32 moles of water, and oxygen is the limiting reactant. Ethanol is the excess reactant. And by the way, it's usually the other way around because the oxygen from the air is usually in excess. A little twist on the matter for you this time. All right, well, let's try method 2. Okay, and this time we're going to start with the 1.75 moles of C2H6O, and I'm going to figure out, if I react that completely, how much oxygen do I need? Okay, so remember method 2, we're comparing the reactants to each other. So if we go back to our balanced equation, it's a 1-to-3 mole ratio. So 3 moles of oxygen for every 1 mole of our hydrocarbon, C2H6O. And we find out that to react that amount completely, we need 5.25 moles of oxygen. Well, if you look at the problem, we only have 4.32 moles available. So again, method 2 agrees with method 1. Either one will work. What that tells us is we don't have enough oxygen to react all of this ethanol. So therefore, oxygen is the limiting reactant. Once we know that oxygen is the limiting reactant, we set up the problem based on the oxygen. So we would set up the problem as with 4.32 moles of O2. Hey, why don't I do the other half anyway, just to prove to you that it works. So if we start with that amount of oxygen, let's figure out how much ethanol we could react. We need to react completely. So for every 1 mole of C2H6O, we need 3 moles of oxygen. And we find out that to react with all the oxygen, we need 1.44 moles of the ethanol. But we started with 1.75 moles of ethanol. Notice that we have more ethanol than we need. So again, either one of those 2 calculations in method 2 point to the same answer. Oxygen is the limiting reactant. Once you know that, you use the oxygen to figure out your final answer. So we know that oxygens are limiting reactants, so we're going to use that to figure out the moles of water. Okay, it's a 3, let's go back to our balance equation, 3 moles of water to every 3 moles of oxygen. Okay, so 3 moles of H2O for every 1 mole of O2. Oops, sorry, it's a 3 to 3 mole ratio. Did you catch that? And there's our final answer. 4.32 moles of water is produced. Oxygen's the limiting reactant. Same as in method 1. I made a link here. You can submit some questions. So please take a minute to submit your questions and let me know where you're getting stuck.